What's in chat? Oh, here, I can resend it. Nope, that is not what I wanted. Okay. I am a boomer in spirit. There, okay. So I'm just gonna go ahead and start. This is being recorded, or it should be getting recorded. I should probably check that before I keep going. Okay, no, we are recording. Cool. So this meeting is to discuss an Arduino design project. As some of you probably know, if you were here in previous semesters, last spring in particular, Scro has done Arduino design projects before. The issue is that we decided to start several weeks before classes got canceled because of COVID, and doing it on the fly was way too difficult to do remotely. So now we're going to try again, being a little bit more prepared. So in the spring, our design project was what we were calling the Smart Lab. So essentially, it was just we were using RFID to try to monitor who was going into the lab, who was leaving the lab, and just so that people can be held accountable if something was left out of place or if something was not cleaned up properly. And so it was just a way of monitoring who was in the lab and making sure everyone was being safe. Sorry. So ever since the previous design project stalled, we were, like the exec board has been discussing proceeding with another lab. So we had talked about continuing the Smart Lab and possibly implementing a project that would be designed to address certain measures of COVID. So we would monitor how many people were going in and out of a certain section of the building or anything like that. But we just weren't sure what would be feasible with what would be with having these projects that relied on people being in a certain location and knowing a certain location, and not being able to access that location because of COVID restrictions. So we ended up moving away from that, and our sponsor Micron, they actually made us a recommendation when we were talking to them about things that we were planning on doing. And so they recommend building up our members' resumes with a more specific project, which is that they're looking for people with experience in capturing data from machinery using microcontrollers like Arduino boards and Raspberry Pis. So we wanted to look into a project that would explore this further, but also simplify it a little bit, because we know that we don't really want people working with high voltage or very expensive machinery that costs $1,000. So our alternative is that we are proposing are $10 coffee makers from Walmart. So what we would be looking for from you guys would basically, we would want you to be getting into groups and monitoring different things that would be going through the process of just making a carafe of coffee, which would be things like the flow rate that the coffee is coming out on, how quickly the carafe is filling up, temperature of the coffee when it comes out, the amount of coffee grounds, voltage supplied to the system, anything like that. You guys would have freedom to choose what you would want to monitor. So, I accidentally made an excess bullet point. So over the course of the next couple of meetings, you guys would be able to form groups. Your groups would basically discuss what you would want to monitor, what sensors you would need, how you would set up your circuit, and you would use this information to set up a budget of what parts you would need to work on the project. And once your budget would be approved by the exec board, we will purchase your parts and supply them to you. And then we would try to set up some sort of system where you guys can safely pass it from one person to the next, so everyone can get a chance to work, to actually work on it. while also making sure that everyone's staying socially distant and not actually just getting in a big group and working on it together. But be aware that the parts that you request may not be the exact ones you get, because most likely we will end up buying these in bulk. And then also the parts will be rented to your group. Once when we give them to you, we expect to end up getting them back. So from here, that's just our general idea of what we want to do. And we're going to move into some Arduino basics. So Arduinos are what are called microcontrollers. They're essentially simple computers on a board that are meant to control actions and features. They typically run a single program at a time. They can have external peripherals like switches, LEDs, motors, etc., and they operate via digital and analog inputs and outputs. So here's a picture of an Arduino Uno, which is most likely analogous to what we're going to end up getting for you guys for the project. Here's more of a schematic diagram of what it actually looks like. So up here at the top, we have digital pins. From 2 to 13, those are going to be your digital pins. Those can be either input or output. And so as an output, it can you have these little ports with these little squiggles next to them. Those little squiggles are meant to identify that those ports are capable of what's called pulse width modulation, which essentially means that they can simulate an analog output when they're just a digital port. And so these ports up here are capable of input or output. I think these are only capable of the pulse width modulation ports are capable of input and output, but they can only perform pulse width modulation as an output. They cannot do it as an input. So if you want to take analog data as an input, you need to use these 6 analog pins that are down here in the corner. That's the important anatomy of this. Other than that, oh, sorry.
What's the word I'm looking for? We're driven and we like to work on projects as a team. That's really all it is.
Sorry, what was that?
I did. No, they weren't accurate. Well, the thing is, okay, it said like the average, the mean.
Francisco, can you mute your mic, please?
Oh, sorry.
You're okay. All right, so back to this. So other than that, the only important anatomy of the Arduino is just this over here. Obviously, it doesn't give a very good depiction of it on this since it's a top-down view. But this is essentially where you would plug in your USB. It's how you would essentially upload your program to your board. Up here is a little reset button. So if you want to clear whatever program is on your board, you just press that button and it will clear whatever program is on your board. Then down here is just another form of power supply. This little black shape down here. It's essentially if you don't want to have your Arduino connected to your computer or anything like that, you can plug in either a battery pack, or if it has the right transformer on it, you can plug it into wall power, and it will supply power. Since the program is hosted on the board itself, you don't need to have it consistently connected to your laptop or your computer. So this is just a way to have it essentially be disconnected from your computer, but still be able to function. So even though that just says that we're done, I still just wanted to take an opportunity to talk about just some other things. I have some of my sorry. I have some of my Arduino stuff with me. So this is what an Arduino Uno looks like for scale. It's about the size of the palm of your hand. So up here you have your digital pins I was talking about. You have your analog pins down here. You also have on the side, I would show you from the top, but it's kind of hard to tell from the top. But on the side where those little white bars are, those are where your ground and your like main voltage are. So it can be at 5 volts or 3.3 volts. And then most likely we'll be giving you one or two of these. These are breadboards. Instead of, these are mainly used for prototyping, but in this case, we'll probably give you a couple just because they're more simple to use than soldering. But basically, all these little holes are just places where you can stick either wires or jumper cables or just LEDs or anything like that, and it'll just hold it there. And it, rather than having everything be connected by wires, each of these rows of little dots, whether that be A through E or F through J, those are all connected together, which helps you create little parallel circuits without actually having to worry about any intensive wiring or soldering. So on here already, I just have like a little tiny little circuit. So I have, oh wait, wrong hand. I have this green wire connected from my positive to the positive terminal of my LED. And then I have a resistor connected from the negative terminal of the LED to the negative. And then let me see if I can actually get everything in frame. I have my little cable. I'm plugging into my Arduino. Now it's getting power. Where do my cables go? And then I can plug in my black cable to my ground and then plug it into my negative, and then take a red cable, plug it into 5 volts, and then plug it into my positive, and it will complete the circuit and the little LED turns on. So this kind of just shows that like all of these little dots in the center, whether that be on the left or right side of this little divide in the center, it's excluding the positive and negative portions on the side. These two divided sections in the center are connected horizontally from each other. So you can just use those as little connections and as a method of wiring them together without soldering, which is why it's good for prototyping. There are, however, soldering breadboards called PCBs. And so these just have little holes in the back that and gold plates, where essentially when you solder wires into here, it'll connect them together similar to how a breadboard works. And so most likely, unless if you guys request it, we will just send you guys breadboards just to simplify things, because I'm not sure how many of you actually know how to solder. So we'll most likely just stick to breadboards if we find that a lot of people would either be interested in soldering or need soldering just for some other reason. We could look into getting some of these and getting some soldering irons too. It's just something that we're going to need to look into when we actually get into making groups and setting aside money for budgets. Other than that, are there any questions about either the projects itself or Arduino basics or anything like that? Is it better prototype before soldering? I would probably say so. I've definitely, I've only used one of these before, and it was for this. This is a web of LEDs that is really disgusting. And I did do this on a breadboard beforehand just to make sure it works. And also it's a lot less time consuming to use one of these than to solder everything. Like this took me several days to do just for these, how many LEDs? 24 LEDs. Granted, this was also for RGB LEDs, so I needed to solder 4 pins for each LED. But still not fun. So I would say probably prototyping before soldering would be a good idea. And because it also is just a proof of concept that your circuit actually works. Sorry, I know this was kind of out of context. They messaged me privately. So Hopefully that answered your question, Chris. Also, I know you can find this online because Arduino is open source. There is a PDF of this book called the Arduino Projects Book that comes with the Arduino Starter Kit, which some of you might have if you're taking elements of electrical engineering or if you took it previously in the past. This book comes with a starter kit. There's PDFs of it online. I would imagine if it's called an Uno, most likely it's just the only difference probably is just that it's not Arduino brand, because Arduino, yeah, it's the same thing. If you just look up, if you just Googled like Arduino Uno, you'll probably end up getting the actual Arduino Uno and a bunch of other microcontrollers that look exactly the same but aren't Arduino. But yes, Emmerich right that even though that's not Arduino, it will still work with the same IDE. They function basically exactly in the same way.
Yeah,
But
I actually have both of them.
oh, you do? Okay, thanks, Colin.
So yeah, and it works with the Arduino Uno program as well.
Yeah. So the only reason why I recommend this book, it doesn't give like a great it does like if you're looking for a good insight into the coding aspects of things, this probably isn't the best starting point. This is a lot more about how coding works with the circuit itself, and I feel like it focuses a bit more heavily on the circuit building than the actual code writing. But it's kind of a good starting point if you're not necessarily sure how to initialize. Here, I can post the book title. It's just called Arduino Starter Kit Projects Books. So most likely if you Google that and then just slap PDF onto the end, oh, whoops, sorry, Chris, I messaged that to you privately. Most likely if you just slap PDF onto the end of that and you put it into a Google search, you'd most likely end up finding a PDF of it. It wasn't very hard to find one. Obviously, if you bought the kit and if you have the kit from EL 3000, you'll most likely still have this book unless if you gave it to somebody else. But it just gives a good basic look at how the code that you're writing is kind of associated to the circuit that you build, and it gives a decent explanation for these different example builds as to like it gives like pretty decent diagrams that you can follow and gives pretty good explanations as to why everything is hooked up to the places that it is. Like it explains essentially why you should be using an analog input versus a digital input, or when it's important to use pulse width modulation, or you can just use a digital output. It's just a good resource to have, but I'm sure there are other similar resources that you can find online. And that's one of the good things about Arduino is that a lot of it is available online. You can find a lot of stuff about Arduino and just coding in general just by a quick Google search, and it will basically give you a pretty good explanation of how things work. I know there was one project I was working on was actually with this sensor. A lot of sensors that you can find on Amazon, they will literally give you links to Wikipedia pages or just websites where they'll give you example code as to how to function with it. So like this is an infrared motion sensor. And so I never used one before, and I used it for one of my projects in EEL. And it basically gave like on the Amazon page, it basically gave me all the information I needed to code one of these. And so just like it, honestly, the internet will be your best resource in finding information out about all of this. If you have any questions, like obviously asking people would probably be another good option, But if you don't know anyone that would know the answer, it probably wouldn't be very difficult to find the answer online either. Any other questions? How's learning Arduino related to actual jobs in the industry? This project is more of, it's not necessarily directly applicable to what you would be doing in industry. It's more of just getting an introduction. The reason why we wanted to do this project in particular is because when we were talking to Micron, when they were talking to us about our sponsorship and things like that, what they basically told us is that they were, oh wait, yeah, Dr. Gila, you can go ahead and answer this one.
All right, thanks. Sorry, I didn't want to interrupt. Hunter was starting down the path. So several companies who come to our Scro case and who have hired Scro members have talked about some additional things. Scro was started by a group of students who wanted more laboratory hands-on involvement in the fabrication side of things of semiconductors. But as all of you know, it's a huge industry that goes from computer programming to chip manufacturing to testing to packaging to sales to finance to HR, right? It's huge. And so what they were encouraging Scro to do was, in addition to the semiconductor fab side, was explore other areas where you can do critical thinking and problem solving. And for instance, one thing that TI and Micron were encouraging was they said that in addition to being a process engineer, which is somebody who knows the process and runs that particular tool, they said they're also interested in what they call a fab engineer. And a fab engineer knows the process, but also knows the equipment inside and out, right? Or can learn that and understand that. Many times they buy a piece of equipment and they will add their own sensors to that to enhance the output of the tool, the data out of the tool that they can record. Or maybe they need flags that says, okay, the wafer is done and the tool doesn't come with that. So they install an optical sensor. So that's all Arduino based, Raspberry Pi based type things. And so they encouraged the club to get more involved in this. Since it's COVID and we can't get in the lab over the summer or other opportunities right now, this is the best thing time that we have to take this opportunity and do this. It's also team building, right? So let's say, I don't know, Hunter, I apologize, I missed the beginning of the meeting, but did you talk about the teams and how they're going to be set up and so forth?
I kind of got into it.
Okay.
I think teams are going to be something that we're going to kind of need to play it by ear to figure out how exactly we're going to do it, since this is the first time we've done anything like this.
Sure.
But most likely what we're just going to have to end up doing is either on a weekly or it can either be weekly or up to the teams themselves on how often they want to exchange equipment or anything like that. But it's most likely just going to be, we're going to set up the Google Doc at some point. Basically just say there are 4 slots per team, see how many people we get signed up, and then everybody can put their contact information into that Google Doc. We can appoint a team captain through that. That will be our point of contact or primary point of contact to the team. And then from there, they can kind of decide how they want to operate things, whether or not they trade just whenever someone has finished one step of the project, or let's say you want to exchange equipment every week or so. That will kind of just come down to their own team planning and things like that. Obviously, if there are issues with people not communicating or people not being willing to pass on the equipment to other people, that's probably when the exec board would need to step in and make sure that things are getting from one person to the other. But other than that, we'd probably encourage people to pass on everything at least once a week to another person. If not, then try to do it every 5 or so days, even more often than a week. obviously once when we pass things out to people, we have no way of directly regulating it unless someone asks us to come in and step in and make sure that someone passes on everything. But I would say try to pass on the stuff once a week per person, or I'm sorry, try to pass the equipment and everything on probably every weekend would be a good point. And just so that everyone can have a fair chance to work with it. And then while that person has it, I would suggest probably working on a Zoom call with everybody else, so that everyone else, even when they're not physically with it, will have an opportunity to have their input applied and have a direct access to help while you're working on it.
Yeah, no, that's really good. And as you point out, every team's going to have a little bit different dynamic, and somebody may have, let's say, a couple exams and somebody doesn't, and so that other person can take it on. Another part that this project will actually help with is, as Hunter mentioned, communication, right? That's a big part of it. In industry, no matter what industry you're in, very rarely are you working alone. You're always working in teams. And those teams can be with people from around the world. So effective communication, responsibility to your team to meet deadlines, those kind of things, that's all part of the professional development. So this project also works in that regard as well. It's not just about making the end product, it's making an end product that everyone contributed to and so forth. There was a Scrum member who got hired by Intel, and when he came back after his interview and told me all what had happened with his interview process, he had mentioned that there was very little technical questions in the interview. They had asked a couple things to make sure he, was what he put on his resume was accurate, but they were more interested in his team dynamics that he got from Scrum. And they were asking questions like, okay, so if you were on a team, was there a situation where one of your team members wasn't pulling their weight, right? And how did the team respond to that? How did you respond to that? So he mentioned that. And in fact, on that question, he said, oh yeah, that was me. He said, I got really behind and because of all these other class projects, and my team members had a conversation, and I understood it. And yeah, so I was able to re-engage. And so, and also safety, things like that. So companies, in addition to your academic background and what you do in the lab, they're also interested in how well you work in teams. And so this is part of that. We can call it professional development or whatever you want to call it, but that's a critical part of any industry. So this Arduino project can kind of give a little bit of all of that. And again, we can't get in the lab, so it's the best thing we have. And again, the companies have even asked for this, right? Like TI and Micron. Are there opportunities to work on these types of things, because they do integrate these little kits and make up their own sensors to put on tools. Micron is starting a new program actually in big data collection and big data management. And they've engaged me and some of the University of Florida in how to jumpstart this. And so we're still in the talking phases of that, but probably by next academic calendar, they want to have a small program and a pilot program in place on this, where not only are the sensors giving real time, let's say a green light or red light, go or no go, but actually collecting data. And then there's some algorithm on the side churning that data to give correction back to the tool or back to the process, kind of give feedback loop. So that's maybe the step or two beyond what this project is. So, but this is a good feed in. So it does correlate with industry, not just in, I won't be building Arduinos in industry, but think of all the other stuff you're doing, the critical thinking, the problem solving, the team building, the communication, all that's critical to any industry that you're in, whether you go into semiconductors, making Cheerios, lumber management, whatever it is, that's all still a critical part of that. So, so Hunter, thank you for giving me a chance to say something. I'll bow out now and let you finish.
All right. The other good point, because I kind of in a way I kind of forgot about it until kind of just now, and it just kind of sparked my memory when you started talking, Dr. Gila, which is that the other thing is that if you participate in this, Micron is also looking to possibly sponsor a I don't have my notepad in front of me from when we were having the meeting, but there are methods of essentially companies sponsoring projects at UF. And what we were looking to do is that Micron is possibly looking into sponsoring one of those projects. So essentially, we would be. It's kind of a weird situation. So it would be Scro representing a project promoted by Micron with students from UF. And so this would kind of just be a good point. I need to pause for a second and just compose myself because I just can't talk today. So essentially, it's going to be a project sponsored by Micron, focusing on essentially what this project is focusing on, about monitoring that data, like what Dr. Gila said, generating algorithms and basically processing that data in real time. But it would be the next step up from this project, where rather than working on something simple like a coffee maker, you would actually be working on actual sensors, creating your own sensors, or using sensors to monitor actual equipment. And so it would be a great research opportunity, and you would have your own sort of freedom on it, because while it would be under the umbrella of the university, it would be sponsored by the company. So it would have a little bit of hand from Micron. They would kind of be directing or having oversight on things. And it would be a group of students who would most likely end up being juniors. It would most likely be a group of juniors, because seniors are probably going to end up being busy with certain projects. So if you're on the underclassmen side of things and you have good success with something like this, that would be a great transition into something like that. And I'm sure there are also a lot of professors, even not associated with what I've been discussing. I'm sure there are also a lot of professors who would be looking for people with experience with Arduino or anything like that. Because like Dr. Gila said, these are just valuable skills to have, not only with just the circuit building side of things, but specifically the coding side of things. If you have a background in coding, even if the job you're looking for isn't necessarily coding based, it could bring you a big step up rather than people who have never had coding background before. So that's also just something to think about. I've definitely been putting more of an effort to try to learn how to code in my own time. I've done dumb little projects like this in the meantime over the summer. I made my my elements of electrical engineering final project way more complicated than it needed to be. But this is just a good method of getting experience you might have not had before, being able to essentially work with people you probably haven't worked with before, gain some professional development, learn how to work and operate a budget, make a proposal, because you are in essence making a proposal to the Scro exec board to essentially give you money, even though you're not going to actually see that money. You're just going to get the supplies. You're just making a proposal to us as to why we should be giving you money for this project and for your project in particular. So it will be a lot of professional development things and things that you will end up coming across at one point or another in college. I'm sure that if any of you have either taken or are in ProfCom, I'm sure you guys have had to look into writing budgets or proposals, or maybe you haven't reached that yet. I'm not entirely sure. But it's something that does become very important, because in the real world, you're not going to have infinite money, or you're going to be working underneath some sort of budget cap. So it's just going to be a good experience all around. Even if you have zero Arduino experience, I'm sure you'll get something out of it, and I'm sure you can contribute to your group, because honestly, Arduino isn't super complicated. It's on the simple side of coding languages, at least in my opinion. And I have almost zero experience in coding prior to working with MATLAB and Arduino. But it's pretty simple, and you can find a lot of resources online, which makes it even easier. So if you're hesitant to participate in this just because you've never had any experience with Arduino, I would say don't worry about it, just go for it. Because even if you don't, I'm sure the people on the Scro exec board who have had experience with Arduino, and even the people who would end up being in your group would be willing to help you, because in the end, this stuff isn't really that hard. Like especially with, right, honestly, the hardest part about this project is probably going to be figuring out how to export your data and make it look nice, because when it comes to actually recording the data, it's not that hard to set up sensors properly. Because in the end, what it ends up looking like is just like converting, like if you wanted to record temperature, converting a voltage value into a temperature by just subtracting from 5 and multiplying by 100, or multiplying, or dividing. No, yeah, I'm just being dumb. It's not that complicated, and everyone will be willing to help you. So don't be scared to do this. It's going to be a great opportunity. It's going to be an opportunity to meet new people. And so, and also just keep in mind that you're not losing anything from this. We're going to be paying for pretty much everything. So you guys do not need to worry about anything like that. So we will supply you with everything that you need. We'll supply you with all the information you need. Your group will be willing to help you, I'm sure. So if you guys are still at all interested, just feel free when the signups come out to just sign up for a team. Other than that, I don't have anything else to say unless if other people have questions.
I think there's a question in the chat.
Was there a question in the chat?
Yeah.
Oh, Chris. Oh, can we still participate if we don't live in Gainesville? That would definitely be a, I'm sure we would be able to get it to work. The main difficult part about it would be being able to get all the equipment to you. Dr. Gila is right. If on the coding side, it would be easier, definitely. But the reason why I'm hesitant is just because obviously you can. You would burn a lot of time because you would be relying on the postal service to send this stuff, and then you would be paying your own money to send things back and forth. So
I mean, does having my own breadboard, wiring kit, and microcontroller, having all that, help?
Yeah, that definitely helps. I mean, in that case, I mean, we could always yeah. Chris, go ahead and message me after the meeting, and we can talk about it more. We can just talk about it more, okay?
For sure.
All right, thanks. Any other questions?
I really wish this stuff was available when I was a student.
Yeah, it's honestly, it's nice. It was also an interesting way to pass quarantine. Definitely have more burn scars now than I did before, but right, if that's, oh, sorry.
No, I was going to just add to what Hunter would said about the Micron project and how this would kind of maybe segue into that, what Micron's proposing. The idea would be to actually install some type of sensors on some of the equipment in the teaching lab. So as an example, we have a thermal evaporator / deposition tool. Thermal evaporator / sputter tool in the teaching lab. And it has 2 vacuum pumps. It has cooling water loops. It has power supplies, all this kind of stuff. And we're really not monitoring any of that other than just some readouts that you look over and say, okay, the vacuum is this, it's fine, we're going to do this. It would be nice to actually start collecting some of that data. What's the pump down speed of the chamber, right? You load samples in there, you start the pump system, and at some point it should pump down to a certain level. We look for pump down rate and we look for ultimate pressure to learn about the health of the tool. If it takes longer to pump down, well, was that an issue with the pumps or is that an issue with the sample outgassing, right? And if it consistently takes longer, okay, we may have a pump issue starting. We want to address that. So there we may be able to be proactive in some of our repairs and maintenance instead of being reactive, meaning the pump died completely, right? As we go from run to run, you want to make sure that your films are very consistent. And so you want to make sure that the water cooling flow is consistent. You want to make sure that the vacuum is consistent, that the power going to the assembly is consistent. If you're doing sputtering, is the pressure and gas flow being consistent. So there's a lot of things that we're setting and not forgetting, but kind of setting, and then you're going and doing other parts of the process. We're not paying attention to that. With a data collection system, it could be collecting that data and then you go back and look at it. What Micron wants to do is something called virtual metrology. That's one aspect of where they believe this is all leading to, which is if you are monitoring every aspect of the process and you run it 10 times in a row and you do metrology on all 10 sets of samples or wafers or whatever, then the 11th time, if the tool and the process reads identical, can you then skip the metrology because you should have the identical process again, right? And how reliant are you then on that data, and can you get that kind of regression analysis out of it? So this is, as Hunter was saying, it's kind of a segue into that bigger Micron project that they're going to want to do. So there, as you develop these skills with the Arduinos, the programmings, getting comfort with assembling circuits, soldering, those kind of things, this can lead to bigger things Micron-wise, but also, as Hunter pointed out, it's job interview stuff. It's also grad school interview stuff that all helps out. So it's a little bit of everything. So don't think that it's only going to be a coffee maker or a bicycle pump or something silly like that, right? It's you have to get started somewhere, and then we're going to go bigger things. I would love to let all of you in the lab right now, but I can't. But on the Micron side, when we get this other project running, some of you may be part of that team that comes in and starts applying sensors to, a $300,000 tool. That's a whole lot more than a coffee maker. But we need you to be practiced in the art of this so that the tool still functions. Okay. So I'll knock out now, but I think I've got enthusiasm on this project. I want to see it take off, and Hunter and the executive team have secured the funding from Micron to make this happen. So, thumbs up to those guys.
All right, thank you, Dr. Yila. So other than that, I don't have anything else to say. Are there any final questions before we start shutting this down? Okay. Other than that, I think we are good here. So if you'd like to, I'll send in case if people came in late, I'll send the login or the sign in one more time in the chat. And then if you've filled that out, you can feel free to leave the call. If you have any other questions, you can feel free to stay for a little bit longer in the call and ask me or anyone else who would have relevant information. But you guys can start logging out if you are good.